Hello everyone. In this video, I will be presenting architecture of 8051 microcontroller. Before going to see in detail about the architecture of 8051 microcontroller, let's see some basic differences between a microprocessor and a microcontroller. Microprocessor, the definition it goes like this. Microprocessor is a programmable clock-driven register-based electronic device which takes in data from a standard input device like keyboards and processes the data according to a program stored in memory and produces results as output. See, microcontroller need to have so many peripherals which need to be connected externally. Whereas all these components collected together on one single chip that forms a microcontroller. This slide shows the basic differences between a microprocessor and a microcontroller. Microprocessor, it is used for multiprocessing. It needs every circuitry externally and it is very expensive. Microcontroller, it is used for specific processing. Every feature is internally present and its cost is very affordable. 8051 microcontroller, which is developed by Intel Corporation in the years around 1978 to 1980. There are other organizations, corporations which have developed different types of microcontrollers like from Philips, Motorola, Zilog. The basic features of 8051 microcontroller are like this. It is an 8-bit microcontroller. It is a 40-pin IC which is dual inline pack. It operates at a voltage of 5 volts. It operates at a clock frequency of 11.0592 megahertz. This is something like a fixed frequency to get exact baud rate. Then it has got 8 data lines and 16-bit address lines. Using these 16-bit address lines, programmer can access 2 power 16, that is 64 KB of memory. And coming to peripherals, what it has got memory, on chip of memory, it has got 4 kilobytes of ROM and 128 bytes of RA. It has got 64 KB of ROM and RAM, which can be connected externally. And IO ports, one more peripheral is IO ports. It has got 4 8-bit IO ports. Timers, it has got 2 timers. Each timer is of 16-bit in size. Serial port, it has got 1 serial port to perform serial data transfer. And interrupts, it has got 5 interrupts. This slide is going to depict a general comparison between basic microcontroller versions from Intel. Features of 8031 microcontroller, which is a predecessor of 8051. It is also having the same 8-bit data lines. It has got 128 bytes of RAM. It does not possess any on-chip ROM. It has got 2 timers and 1 serial port and 3 interrupts. 8051, as now just we have seen, it has got 8-bit data lines, 128 bytes of RAM, 4 kilobytes of ROM, 2 timers, 1 serial port, and 5 interrupts. The successor of 8051, that is 8052, with some add-ons like it has got 256 bytes of RAM, 4 kilobytes of ROM is the same, and timers, it has got additional timer. So 3 timers, 1 serial port, and 1 additional interrupt. So 6 interrupts in total. See the architecture of 8051. When we draw an architecture is defined as arrangement of various logic blocks on an integrated circuit logically. The first block what we concentrate about a processor or a controller is ALU. ALU stands for arithmetic and logical unit. 8051 ALU it is of 8-bit in size. Here you can see in the slide, it is ALU, which is of 8-bit in size. So this ALU, it is driven with two temporary registers, which are again 8-bit in size. And all these peripherals, what have been connected on the architecture, they are of they are connected with 8-bit internal data bus. Every processor or controller is going to have internal working registers. Here we have got two internal working registers by name A and B. A stands for accumulator, B is a B register. Accumulator is implicit for all AL related operations what are being carried out by 8051 microcontroller. B register is an additional register which is exclusively used when 8051 is performing multiplication and division operations. And here we have got RAM, EPROM, which is ROM, that is on-chip ROM. And see the ports. Okay, here we have got 4 ports: port 0, port 1, and port 2, port 3. Okay, then apart from this, what we have got or what we need to program is, see, we have got address RAM register. See, on chip we have got addresses like for RAM, which is of 128 bytes. We have got 0 to 7F addresses. In that 0 to 7F, the lower 32 bytes, they are allocated for 4 register banks, namely R0, R1, R2, and R3. Each bank is going to have 8 registers. Each bank is going to have 8 registers, namely R0 to R7. To select one particular register at a time, we will be having a definite address that is given by a program counter. Program counter is a register which is going to hold the address of next instruction to be fetched. Okay. If at all the address is, program counter is also a 16-bit. It is a 16-bit register. Like we have got 16-bit addresses. Data pointer, DPTR, which is also a 16-bit register, which can be accessed as two 8-bit registers. One is DPL, data pointer low, lower bit. Another one is DPH, data pointer high. Okay, then program incrementer, say, as all processors and controllers they are sequential machines, they will be executing instructions sequentially. Okay, then what? Okay, oscillator is the external crystal oscillator. What we have, what is the clock we are connecting? That is 11.0592 megahertz crystal. We will be connecting to generate that exact frequency. And using that crystal oscillator, we will be generating a clock frequency, and each instruction, how much time it requires, that will be analyzed by timing and control circuitry. Okay, and then a instruction register which is going to hold the current instruction to be executed. Apart from these, there are different special function registers available on the architecture. Like for when programmer is interested in operating timers, timer registers like TCON and TMOD, that is timer control register and timer mode register. They are used to perform, or when programmer is performing timer related operations, he will be making use of these special function registers to program timer. As just now we have seen, timer is a 16-bit register. We have got 8-bit data length. To load that 16-bit data, which is not done at once, so timer is again divided into 2 halves, timer low and timer high. Then serial control, one more register. When controller is performing serial data transfer. Programmer will be using serial control register. Then two special function registers with respect to interrupts. One is interrupt enable, another one is interrupt priority. These are some special function registers. They are associated with 8051 microcontroller. And one more register is the stack pointer. Stack is a data structure which allows data to flow in last in first out fashion. Every stack is associated with a pointer, and that is termed as stack pointer. Stack pointer always points to top of the stack. Whenever there is a data present on the stack, at that particular position, pointer will be indexing. Okay, this is all about 8051 architecture. Thank you.